A college administrator claims that 77% of college students purchase their books from the college bookstore. You think this is inaccurate and form a random sample of 113 students at that college and find that 97 of them purchase their books from the bookstore. Test the administrator's claim using a level of significance of 1%. What type of test will be used in this problem? Well, the easiest way to determine what type of test is going to be used is to identify what the claim really is. So the claim is that 77% of college students purchase their books from the campus bookstore. So if we parse out the information that's really needed there, we would say that the claim is the percent of all students, all the college students at the campus, that purchase the books in the bookstore is equal to 0.77. So this is a percentage that we are testing. So in statistics terms, what we say is a proportion. So this is going to be a test for a proportion. Now, ultimately, this would depend upon using a binomial distribution. But because binomial distributions can be approximated by normal distributions under the right conditions, what we're going to say is that we're going to use the 1-prop z-test, which is based off of normal distributions in the calculator. And we can use that so long as n times p and n times q is greater than 5. So n is the number of items in the sample. So n would be 113. P is the value from the null hypothesis, 0.77. Q is 1 minus that, so 1 minus 0.77, which is 0.23. So to verify that this test can be used, what we need to do then is take 113 times P and then 113 times Q, and just make sure both of those are larger than 5, which in this case they are. So that justifies the use of this test. The next thing that we need to do is take our claim and list it as either the null or alternative hypothesis. So the claim was P is equal to 0.77. Since there is a statement of equality, that becomes the null hypothesis. And I'll go ahead and mark that. That was the claim. And the complement becomes my alternative hypothesis. So the original claim, was it located in the null or alternative? It was in the null. And now we are asked for the critical value and, in fact, that should state the test statistic. That wording's not really completely correct. So what is the test statistic for the given statistics, and what is the p-value for this test? So we're going to get that information from the calculator. And if you go under Stat, slide over to Tests, and come down to 1-prop z-test, the function we decided upon earlier. Enter the value that we got from the null hypothesis, 0.77. X, this is the number of items that favor your event from the sample. So we had a sample of 113 students, so that's our sample size, n, and of those, 97 used the campus bookstore. All right, so that would be X. Now the next statement is asking what type of test do we have? And it's either a two-tailed, a left-tailed, or a right-tailed. And effectively, all you have to do is just match the symbol that's in the alternative hypothesis. This would be a two-tailed test, because it's not equals. All right, now we hit calculate, and the first thing that we get is the test statistic, which is 2.23, And I'm going to round that to 2 decimals, but follow any rounding rules given in the problem. The p-value, 0.0255. I'm going to take that out to 4. All right, what is the decision based on the given statistics? Well, to get the decision, we take our p-value, and I know there's lots of the letter p gets floating around here quite a bit in these kind of tests, but just remember what each one means and what it's referring to as best you can. The p-value we just came up with as a percentage was 2.55%. We compare that to our level of significance, which is the alpha level. And here the level of significance was 1%. So the p-value is bigger than alpha. So if p is low, the null must go. So if the p-value is larger than alpha, what we say is we fail to reject the null hypothesis. So the decision is fail to reject the null hypothesis, and the correct interpretation, using a 1% level of significance, there is not sufficient evidence, because we go with the weaker of these two statements. So if we reject the null hypothesis, that's a very strong result. So we use stronger language, just is. If we fail to reject, we use the weaker language, which is not. So there is not sufficient evidence to blank the claim that 77% of students purchase their books from the bookstore. So we're trying to either support or reject it. And in order to decide that, we can say if the claim is in the null, we're trying to reject it. And if it's in the alternative, we're trying to support it. That's an easy way of determining. But another way is if you follow the logic, so we are failing to reject the null hypothesis. And that's not saying that it's true, but for argument's sake, we'll state that means it's true. All right, and it's not really true, but kind of true-ish, sort of. All right, which means the other statement then would be false. All right, so we're saying this is a true statement, and that implies that the claim is true because this claim is in the null. So what we want to do is we want to word this in such a way that it's true, but it's not a very strong result. So instead of saying there is sufficient evidence to support, we say there is not sufficient evidence to reject, and that's in favor of, but it's not really strongly in favor. So that's how we work through that.